Hello, everybody. In statistics, this is Professor Ken. And I'm here in Red Square in Moscow in front of St. Basil's Cathedral. Okay, so we have a test on Tuesday, and there's going to be 5 questions. I wrote a guide of the objectives, but I'm also going to give you 5 sample problems right now, and I'm going to do them out for you. And hopefully, this video will be useful. And hopefully, you'll have enough character to write me back and say, gee, Professor Ken, this was a very useful video. Thank you so much for taking your busy time out to make it for us, even though you didn't have to. That's what I'll be expecting from all of you. All right, so let me share my screen. And I'm actually going to stop the video so that my stupid face isn't in the way. Okay, great. And here we go. All right, so question number 1, the mean height for men is 70.5 inches, and that's for the whole population with a standard deviation of 1.1 inch. What is the probability of a randomly selected man having a height between 71 and 73 inches? So I'm going to go to draw mode. And the first thing I'm going to do is draw our graph. Since it's for the population, it's a z distribution. And down here we'll have our x values. So this would be 0. Here's where we put the mean of 70.5. All right, so the mean is equal to 70.5. And the standard deviation, is equal to 1.1. And we want to know what's the probability of going in between 71 and 73 inches. So we're trying to find the area between these two partitions, and we need the z-scores for each of those two x-scores. So to find z, we do the x value minus the mean divided by the standard deviation. So for 71, it'll be equal to 71 71 is to the right. I can't believe I did that. All right. Let me start over again. Bottom. Okay. So we know that the mean is equal to 70.5. I can't believe I made 71 to the left of the mean. Standard deviation is 1.1. Let's draw our graph. So here's z. Here's x. Here's 0, which is 70.5. And here is 71. And here is 73. So now we need z-scores for 71 and 73. So to find that the z-score for 71 is going to equal 71 minus 70.5 divided by 1.1, which is equal to, I'm just going to do a quick on my Desmos on my phone, so I don't have to be jumping back and forth. All right, so I'm going to do, let's all learn together. All right, so we're going to do 71 minus 70.5 divided by 1.1. And that's 0.45. And now I'm going to do my z-score for, so let's put it up here right away, 0.45. Now we have to find our z-score for 73. So for 73, it's going to be 73 minus 70.5 divided by 1.1. And that's equal to, I'm doing it on my calculator right now, 2.27. Okay, so here's our partitions, and we're trying to find the area between those two z values. So I'm going to look at a 0.45 on my z table, and that's going to give me this area to the left of 0.45. Then I'm going to look under 2.27 on my z table. That's going to give me the area to the left of 2.27. I'll subtract those two areas to get the area in between. So here's let's zoom. All right. That's what my little bookmark thing. There's my Z table. So the first one I'm going to look under is positive 0.45. Who the heck is that? Get away. All right, so positive 0.45 is right here, 0.6736. So this is 0.6736. And then down here, 2.27. Let's see what that's going to be. 2.27. 0.9884 right here. 2.27 is 0.9884 because this is 2.29, 2.28, 2.27, 0.9884. 0.9884. So that, whoo, where'd it go? I got other ones open. I'm going to close them right now so they don't get in the way. Okay. What is going on? My goodness gracious. All right. It's not letting me touch it, so that is not good. All right, here we go. So it's 0.9884 minus 0.6736 equals 8,413. So the probability that 71 is less than X which is less than 73 equals 31.48%. Okay, good times had by all. Let's do this second question. Okay, the mean weight for women is 142 pounds. Mean 142 with a standard deviation of 2.2 pounds. What is the probability that 9 women will have a mean weight less than 141.5 pounds? All right, so we're dealing with not an individual woman, but with 9 women. So n equals 9. And all that means is we have to change our standard deviation to the standard deviation of the sample mean, which would equal 2.2 divided by the square root of 9. And that would be 0.7 something. 2.2 divided by 3, 0.73. All right, let's draw a picture of what is going on. So it's a Z distribution. So here's Z, here's X. The mean on Z is 0, the mean on X is 142. And we're looking for less than 141.5. So let's put it right here, 41.5. Here's our partition. And we need a Z-score for 141.5. And then we'll look it up on the table, and that will give us our area to the left. So we're looking for the area to the left of the partition. So let's determine our z-score. Z is going to equal 141.5 minus 142 all over 0.73. Because we have to adjust the standard deviation to make it the standard deviation of the sample mean. All right, so that's 141.5 minus 142 divided by 0.73. I'm doing it on my calculator. Negative 0.68. Okay, now that's right here. Negative 0.68. All right, let's get that area to the left by going to our z table and finding negative 0.68. All right, so here's negative 0.69, 0.68, 0.2483. So that's in here, 0.2483. So the probability that x is less than 141.5 is equal to 24.83%. We could also say that 24.83% of all women weigh less than 141. Oh, no, we can't because it's a group of 9. So the probability that 9 women will have a mean less than 141.5 is equal to 24.83%. Beautiful. Okay, let's go to the next one. Okay, out of 141 basketball players sampled, 23 tore their ACLs. So create a 95% confidence interval for the proportion of all basketball players who tear their ACLs. All right, so we have n equals 141. This is proportion, so it's a z distribution. P hat is equal to 23 over 141. And we're creating a 95% confidence interval, so the area to the left, well, the areas of our tails are going to be 0.025. That off over 2. All right. So what's 23 over 141? Do it on my calculator here. 23 divided by 141.163. Okay, let's draw a picture. So there's Z. Here's P, because it's proportion. So this would be 0. That would be 0.163. And we're doing a 95% confidence interval. So the area of this tail is 0.025. And the area of this tail is 0.025. And the area in between would be 0.95. So we are estimating the proportion of the population. So let us now go to our document, which is right here, and we're estimating the proportions up here, the first one. And there's our Desmos. All right, so P hat, it says P stands for P hat, which is different than what we learned today for the other thing. P hat's 23 over 141. 23 over 141. N is equal to 141. Let's put a negative z here so we can get our area right. Now we want that area to be 0.95. So therefore up here, we're going to put the area to the left of the partition is going to be 0.975. And there we have 95% area shaded. And our critical z is 1.96. Let's put that in right away. So this is 1.96. And this would be negative 1.96. Now we have to find, we don't want that. Okay. This would be our lower limit, and that would be our upper limit. So our lower limit is 0.102, and our upper limit is 0.224. 0.102, 0.224. 102 and 0.224. That 0.102 looks terrible. 0.102, much better. So our confidence interval is the probability. We don't need that. Is that 10.2% is less than P, which is less than 22.4%. So how do we interpret that? We'll interpret it with the text box. So with 95% confidence, the probability of basketball players, we could also say the proportion of basketball players who tear their ACL is between 10.2% and 22.4%. And that problem is done. We only got 2 more to do. How about that? Okay, next one. A sample of 22 giraffes, or should we say giraffes, giraffes, showed that their neck length had a mean of 6.5 feet and a standard deviation of 0.22. Create a 99% confidence interval about the mean neck length of all giraffes. All right, so we have X bar. I don't like that. It's twirling like that. Hang on. So, well, not on. What is going on? It's supposed to be in writing mode. It's not. Okay, X bar. Whoa, I don't want that. Huh. Equals 6.5 feet. I don't know why it does that. And the standard deviation of the sample is 0.88. And n is equal to 22. So this is a t distribution, 21 degrees of freedom, but Desmos will do that for us. And we're creating a 99% confidence interval. So alpha is going to equal 0.01, and alpha over 2 is going to be 0.005. So if we draw a table, here's our curve, and we call this t, call this one x. There's 0. There's our mean of the sample, 6.5 feet. And this is going to be 0.005. And this is going to be 0.005. This is going to be 0.99. Okay, so we need to find the critical values for our partitions, and then we need to find the lower limits and the upper limits. So let's go to our document here, and we're doing estimating the population mean. So our mean was 6.5 feet. And our n value was 22 giraffes. Our standard deviation, I don't remember. I have to look it up. 0.88. And our alpha was 0.01. Let's see if it did it correctly. Nope, because it's only 98%. We want 99%. So alpha is the area of the tail, 0.005. There, that's better. All right, so our critical t-value, now we know it's 0.005 because we need that 0.99 there for 99% confidence. So our critical t-value is 2.83. Let's mark that in. So this would be 2.83, and this would be 2.83. My goodness. Something very bad happened. Okay. And scroll down a little bit. Okay, great. And now let's find our lower and upper limits. Our lower limit's going to be right there. And our, oh, this is negative 2.83, positive 2.83. So let's go back to Desmos. Our lower limit is 5.97. 5.97. And our, I just want to make sure I did everything correctly. 6.5, 22 giraffes, 0.88, 5.97, and 7.03 is our upper limit. And we see that 6.5 is right in between. So we say that 5.97 feet is less than the mean neck length, which is less than 7.03 feet. And that makes perfect sense. So what's our interpretation? We'll insert a text box. We are 99% sure that the mean neck length for giraffes is between 5.97 and 7.03 feet. Perfect. Okay, let's get to the last one. Okay, so we're estimating standard deviation now. So it says the standard deviation for the length of time a student keeps a pen in his pocket without breaking it is 3.5 days. That's S. Here we go again. S equals 3.5 days. And that's if we sampled 36 students, so N equals 36. Estimate the standard deviation for pen time for the entire population with 90% confidence. So alpha would be the area of each tail would be 0.05. All right, so now this is a chi-square distribution because we're estimating standard deviation. So this graph looks like a roller coaster, or if you're Landon, it looks like a whale, which I can't disagree with. So here's chi-square. Here's our standard deviation. So chi-square starts with a 0 over here. And the mean standard deviation, or the standard deviation that we're looking for, is 3.5. Now, if we're doing 90%, the area of this tail would be 0.05. And the area of this tail would be 0.05. The tail on the right is long and skinny. The tail on the left is short and stout like me. All right. So let's go to our documents, find out which one we better use. Now we see that we're estimating the standard deviation. So it doesn't do it on Desmos, so we have to do it on Excel. So our N value is 36. Our standard deviation was 3.5 days. Our confidence interval is 0.9. So the area of our right tail would be 0.05 and our left tail would be 0.95. So our critical values are 22.4 or 0.5. Let's put that in. So this would be 22. Ooh, my goodness. This would be 22.5. And on the other side, where we have 49.8. Woo. 49.8. So now we need to get the corresponding lower and upper values that correspond to 22.5 and 49.8. So the lower standard deviation is 4.4. And the upper standard deviation is, lower is 4.4, upper is 2.9. Lower is 2.9, upper is 4.4. And we can see that 3.5 is closer to 2.9 than it is to 4.4, which is what we want to see because of the shape of the curve. We see that the center point is closer to the left. All right, so what's our interval? We can say that 0.9 is, that's a point, is less than the standard deviation of the whole population, which is less than 4.4. And that's all in days it takes to break the pen. So if we want to interpret this, I'm going to use a text box. All right, draw the text box. So we can be 90% certain that the standard deviation for keeping a pen without breaking it is between 2.9 and 4.4 days. Okay, so let me stop the share. Turn on my camera. Ah, here I am. Hi. Okay, so you're gonna have 5 problems on the test. I did them in about 35 minutes, and that was with explaining everything step by step. So if I can do them in 35 minutes, you could do them in an hour and 15. I am sure of that. Okay, but you got to study, study, study. You got to practice, practice, practice. If you don't study, study, study. If you don't practice, 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 you're gonna fail, fail, fail. All right, everybody. Good luck. Happy Easter. And this is Professor Ken. I am outie.